Today I am going to solve quadratic equation problem in 2020 combined maths day. This is the question. They are given that two functions fx and gx, and they are given that pq are real numbers and c is a positive number. Then problem say that fx equals 0 and gx equals 0 have a common root alpha, and show that alpha equals p minus q. Right. First we are going to solve this part. I am going to rewrite the equations. First equation is x squared plus px plus c equal 0. They said that the alpha is a root of this equation. Then alpha must satisfy this equation. Alpha squared plus p alpha plus c equals 0. Then I am taking second equation, 2x squared plus qx plus c equals 0. Alpha is a root of this equation, so the alpha must satisfy the quadratic equation. 2 alpha squared plus q alpha plus c equals 0. I am taking this as my first equation and this as my second equation. As you can see, we have to show that alpha equals p minus q. There is no c term in our expression. So, using these two equations, I am going to cut out c term in these equations. So, I am taking 2 minus 1. I am subtract first equation by 1. Then 2 alpha squared plus q alpha plus c minus alpha squared minus p alpha minus c equals 0. I am going to simplify this. 2 alpha squared minus alpha squared is alpha squared. I can take alpha out from the q alpha minus p alpha term. Then it gets q minus p into alpha equals 0. I divide the whole equation by alpha, then get alpha plus q minus p equals 0. Then alpha equals p minus q. I obtain the first expression. Now I am going to solve the second part. After that they said find c in terms of p and q. Okay, now we have to find the value of p. Value of c. To find the value of c, I use two quadratic equation which satisfy the alpha. Okay. First one is alpha squared plus p alpha plus c equals 0, and the second one is 2 alpha squared plus q alpha plus c 0. Now I am going to multiply first equation by 2. Then I obtain 2 alpha squared plus 2p alpha plus 2c equals 0. I take this as my third equation and I am going to find the value of c. So I subtract second equation by first one. Then 2 alpha squared cut out. I get alpha value as 2p minus q alpha. 2c minus c means plus c equal 0. Then I can take c as minus 2p minus q alpha. Alpha we have find above what? Alpha is p minus q. Now I am multiply minus mark with the bracket and simplify this as q minus 2 p minus q. This is the value obtained for the C using q and p. Okay, next part. They are given some inequalities to show. Right. For that, I am using my C value. They given that C is a positive number. My C value is C equals q minus 2p into p minus q. In the problem, they given that C is greater than 0, which means C is a positive number. If C is positive and we obtain C from multiplication of two numbers, so these two numbers might both are positive or both are negative. I am considering that situations. First, I am considering these two numbers are positive. Then, if these two numbers are positive, I can write q minus 2p greater than 0, which implies q is greater than 2p. And second one is p minus q greater than 0, which implies p greater than q. If p greater than 0, if p is a positive number, these two inequalities cannot be happen. You can see p is greater than q and here q is greater than 2p. This cannot be obtained if p is a positive. If p is negative, these inequalities are correct. Then I cannot obtain these inequalities as true. These are false when the p is positive number. So I am considering these two numbers are negative as negative. So I write in another color. Then q minus 2p smaller than 0, which implies q smaller than 2p, then p minus q smaller than 0, which implies p smaller than q. If p is a positive number, as you can see, these two inequalities are true. Q can be greater than p and also q can be smaller than 2p. If p is a positive, then this is a valid inequality. So I can take as this. If p greater than 0, then I combine these two inequalities and I can write this p greater than q and 2p is greater than q, and I obtained my inequality. Now we go into the next part. Then we have to show the discriminant of fx is 3p minus 2q square. Okay. We have to find the discriminant of fx equals 0. Given that fx equals 0 is x squared plus px plus c equals 0. I know that discriminant is b squared minus 4ac in standard form. So I have to substitute values. B squared means minus b squared, so plus b squared minus 4. A means 1, C is C. Then I obtain P squared minus 4C, and I have a value for the C. I substitute it here. I get C as Q minus 2P and into P minus Q. Now I expand two brackets. Q into P means PQ. Q into minus Q squared. Minus 2P into P minus 2P squared. Minus into minus plus 2P Q. Now I multiply equation by negative 4. Minus 4PQ plus 4Q squared minus 8 plus 8P squared minus 8PQ. And I simplify this. 8P squared plus P squared 9P squared minus 4Q minus 8PQ minus 12PQ plus 4Q squared. Now I can write this as 9P squared. I can write square root of 3P, and I can write this as minus 2 times 3P into 2Q and 4Q squared as square of 2Q. Then I can see this is the expansion of complete square. So I can write this as 3P minus 2Q square. I am obtained given discriminant value. Now we go into the next part. Let beta and gamma be the other roots of fx equals 0 and gx equals 0 respectively. Show that beta equals 2 gamma. Okay, we have to get relationship between beta and gamma. Given that they are the roots of other roots of given equation. So I write equations x squared plus px plus c equals 0, which have roots as alpha and beta, and 2x squared plus qx plus c equals 0, which has root alpha and gamma. Then I can write addition of roots and product of I can write alpha plus beta as minus p and alpha dot beta as c. Here I can write alpha plus gamma as minus q divided by 2 and alpha dot gamma as c divided by 2. To obtain relationship between beta and gamma, I can use the product of these roots. So if I divide products of roots, I can obtain relationship between beta and gamma. I use this equation and this equation. I divide it. Okay. Then alpha gamma divided by alpha beta. Then c divided by 2 divided by c. As you can see, alpha to alpha, c to c. Then I cross multiply. Then I can obtain beta equals 2 times gamma. Then we have to find the quadratic equation whose roots are beta and gamma. Also show that the quadratic equation whose roots are beta and gamma. Okay, let's find the quadratic equation whose roots are beta and gamma. I can write the quadratic equation whose roots are beta and gamma as this: x squared minus addition of roots beta plus gamma x and product of roots beta dot gamma equals c. So I have to find the beta plus gamma and beta dot gamma. Then I can substitute it to here and find the given equation. So to this I am using above expressions I use for the additions of roots and multiplication of roots, right? Which I use different color. I obtain alpha plus beta as minus p, alpha plus gamma as minus q divided by 2, alpha dot beta as c and alpha dot gamma as c divided by 2. First I am going to find beta plus gamma. I add sum of two roots equation, this equation and this equation. Then I get 2 alpha plus beta plus gamma equals minus p minus q divided by 2. I can get value for the beta plus gamma as this. I take in common root minus 2p minus q divided by 2. This term we come to this side and minus 2 alpha. We have value for the alpha as p minus q. I can simplify this: minus 2p minus q. I take in common denominator, then this becomes minus 4 minus 4p and plus 4q divided by 2. Then my value beta plus gamma becomes minus 2p minus 4p minus 6p minus q plus 4q is plus 3q divided by, and I can take 3 outside, then q minus 2 divided by 2. This is the value obtained for the addition of root. Then I am going to find the multiplication of root. I multiply alpha dot beta and alpha dot gamma. Then I obtain alpha squared beta gamma equals c squared divided by 2. I can subject beta gamma as this: c squared divided by 2 alpha squared. We have obtained values for the c and alpha. I am going to substitute them. Then beta gamma equals c value is q minus 2p squared into p minus q squared, and alpha value is p minus q squared. As you can see, p minus q squared, p minus q squared, and I get value for the beta dot gamma as q minus 2p squared. This can be written as 2p minus q also, no difference. Q minus 2p squared can be written as also 2p minus q squared. If you have a doubt, you can expand both of them and check it. Now I am going to substitute these to my equation, which is x squared minus additions of root 3q minus 2p divided by 2 x plus 2p minus q squared divided by 2 equals 0. Then I can multiply equation by 2 and I am getting negative mark out from this bracket. Then this becomes 2x squared. When negative marks come outside, it is plus 3 and 2p minus q divided by, sorry, not 2, x plus 2p minus q squared equals c. I obtain the given quadratic equation. Roots of this equation is beta and gamma. We completely solved the quadratic equation in 2020 A-level pass paper. In next video, I am going to solve the quadratic equation problem in 2019. See you in that video. Thank you.